Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The Invisible Genius: How Heinrich Hertz Revolutionized Modern Communication. You've probably heard of the name Hertz, but no, he's not some CEO from a tech giant, nor a superhero from Marvel movies. Hertz was the driving force behind modern wireless communication. Without him, you wouldn't be sending voice messages on WeChat or streaming YouTube videos. Hard to imagine, right? A physicist whose work we might think is distant from our everyday lives ended up changing everything. Born on February 22, 1857, in Hamburg, Germany, Hertz grew up in a family steeped in academia. His father was a businessman, and his mother came from a scholarly background. So, from a young age, Hertz was forced, let's say encouraged, to live in an environment where deep discussions about science and ideas were the norm. Imagine a 10-year-old Hertz sitting at the dinner table, overhearing his parents talk about how electricity could impact the economy. But deep down, he's probably thinking, who cares about that? I just want to know how electricity flows through my wires. Now, here's the kicker: Hertz's dad had big plans for him to become an engineer, just like many parents dream for their kids, right? But young Hertz? He wasn't having any of it. He was obsessed with electricity and couldn't care less about making money. I mean, who wouldn't want to make electricity feel magical? And sure enough, Hertz's brilliance began to show at the University of Göttingen, one of the world's top academic centers at the time. This place wasn't just any university, it was a breeding ground for geniuses. So when Hertz arrived, he wasn't just a student, he was practically the star kid of the academic world. With the mentorship of professors and access to cutting-edge knowledge, Hertz quickly found his footing. At Göttingen, you could imagine Hertz as the social butterfly among the best mathematicians and physicists of his time. Picture the scene: a group of scholars discussing problems till late in the afternoon, not solving anything, but saying, "This is fun. Let's keep going." Over coffee, ideas kept flowing. Hertz wasn't just another brilliant mind. He was also the guy who loved sharing his thoughts, and at the same time, he knew how to take in feedback. While he was no genius from the start, his humility helped him soak up wisdom from his peers and professors. That's what laid the groundwork for his future breakthroughs. It wasn't just his parents' support that shaped him. Hertz's upbringing in an academic household left a lasting impact. Picture young Hertz, sitting at the dinner table, chatting with his mom about the theory of electricity and listening to his dad's business talk. It was this unique combination that made Hertz into the scientist we know today, the one who opened the doors to wireless communication. Now, do you think Hertz was born a physics prodigy? Well, think again. Like many great minds, Hertz had his struggles too. Believe it or not, he was once a lost student in the maze of formulas and electric currents, unsure of where to go. He doubted himself at times, and guess what? That confusion and frustration fueled the breakthroughs that made him legendary. Hertz's journey at Göttingen wasn't as smooth as it might seem from the history books. Even in one of the best academic institutions, Hertz started out just like any other student, eager but inexperienced. Göttingen was a place where theories were new, and every class felt like unwrapping a century-old puzzle. Hertz's growing fascination with electricity wasn't because he knew it would lead to groundbreaking work on electromagnetic waves. No, it was simply because he found electricity itself fascinating. Who else could find joy in a pile of wires and electric currents? Well, Hertz certainly did. But here's something surprising: at this stage, his interactions with fellow students weren't all glam and glory. Instead, they were about discussing basic electrical problems, debating tiny details, and even getting a few things wrong. Hertz didn't rush to share his ideas or seek attention. He was just genuinely fascinated by physics. The real turning point came when he crossed paths with one of the greatest physicists of the time, Hermann von Helmholtz. If there was anyone who could change the trajectory of Hertz's academic life, it was Helmholtz. He was the one who introduced Hertz to the deeper complexities of electricity and electromagnetic phenomena. Imagine having the chance to learn from Helmholtz. For any young scientist, that's a huge break. And for Hertz, it was a game changer. So, let's be clear, Hertz didn't just become the groundbreaking scientist we remember overnight. It wasn't instant genius, it was years of hard work, failures, and breakthroughs that led him to his ultimate path. Göttingen didn't just build his scientific knowledge, it built his resilience. He learned that true academic success isn't just about formulas. It's about finding opportunities in the most unlikely places. Thanks to Helmholtz's guidance, Hertz finally understood that electricity wasn't just about lighting up bulbs. It could also travel through the air in the form of radio waves, revolutionizing global communication. That was his mission. Through it all, Hertz's perseverance, wit, and love for electricity pushed him toward becoming the pioneer of wireless communication. It wasn't luck. It was hard-earned success. Now, you're probably wondering, how important was Hertz's discovery of electromagnetic waves? Well, without him, we might still be waiting for wireless tech, radio, TV, Wi-Fi. These things might have been centuries away. Imagine a world where you still had to use landlines for calls and wait for paper newspapers to get updates. Sounds like stepping back in time, right? But thanks to Hertz, we have the tech we rely on today. He's the unsung hero who paved the way for wireless communication, basically the father of Wi-Fi. Let's rewind to 1887. Hertz's experiment wasn't flashy. It didn't make headlines, but it quietly changed the world. At Kiel University, he set out to test Maxwell's theory of electromagnetic waves. Back then, people were skeptical. How could electricity and magnetism travel through the air as waves? Well, Hertz proved it wasn't just theory. He showed that these waves could travel great distances, just like Wi-Fi signals. His experimental setup may have seemed simple, but it required incredible precision. Using an oscillator and a receiver, Hertz successfully generated and detected electromagnetic waves. He demonstrated how these wireless waves could propagate through space, just like the technology we use today for things like Wi-Fi. His work was the foundation of what we now take for granted. In the end, Hertz wasn't just a scientist. He was the key to unlocking a new era of communication. And that, my friends, is why we can now chat across the globe without wires. You might be wondering, how exactly did Hertz pull off these seemingly impossible feats? Sure, he had an exceptional talent for physics, but his success didn't come out of nowhere. Using incredibly precise equipment, Hertz designed an oscillator capable of generating electromagnetic waves, and paired it with a highly efficient receiver to capture the waves it produced. But here's the real kicker: Hertz didn't just prove that electromagnetic waves existed. He made a jaw-dropping discovery. The speed of these waves was identical to the speed of light. This meant that electromagnetic waves and light waves were part of the same family. In other words, electricity and magnetism could travel through invisible space, changing the way we thought about the universe. This revelation shattered many old ideas in physics and laid the groundwork for the wireless communication tech we now rely on. Imagine if Hertz hadn't conducted this experiment. We might not have had radio broadcasts or even television by the early 20th century. Without electromagnetic waves, wireless tech would have had no solid theoretical foundation. Heck, we might still be relying on wired networks to transmit data, and the very idea of using mobile phones could have been pure science fiction. Hertz's setup and experiments were not just about theory, they were about proving things in practice. His oscillator wasn't just generating waves, it could control their frequency, essentially letting him fine-tune the waves like a musical instrument. Each successful step in his experiments opened up new doors for future scientists. What's even more mind-blowing? Hertz was able to receive these waves and use them for communication. In short, he made wireless transmission a reality. His experiment didn't just prove Maxwell's theories, it turned them into something tangible, something that future inventions could be based on. Radio, television, and even satellite communication all owe their existence to Hertz's discovery. When Hertz showed that electricity and light are essentially the same, he didn't just push the boundaries of physics, he redefined how we interact with the world. His work made it clear that electromagnetic waves weren't just a theoretical concept, they were real, and they could change the world. Today, when you send a message, browse the web, or watch TV, it's all thanks to his experiment. It's wireless, because of Hertz. Pretty cool, right? Hertz's experiments also revealed a deeper truth: Physics isn't just about abstract formulas, it's about testing ideas, proving them in the real world, and transforming them into something practical. Hertz wasn't just a great physicist, he was a pioneer willing to challenge the rules of nature. By experimenting, he proved that electricity and magnetism could be harnessed and used for something as revolutionary as wireless communication. That's why his place in the history of physics is firmly cemented. Imagine Hertz, sitting in a modest lab, holding electrical equipment in his hands, yet his mind was buzzing with curiosity about the unknown. Little did he know, his small experiment would eventually influence radio communication, television broadcasting, and even the internet. Today, when we use our phones or connect to Wi-Fi, we owe it all to Hertz's waves in the air. So, the next time you use Wi-Fi to browse the web or kick back with a TV show, remember, Hertz's electromagnetic waves are quietly working behind the scenes, making modern tech what it is today. This isn't just Hertz's contribution, it's a victory for human ingenuity. But let's not forget, Hertz wasn't just a master of experiments. His scientific thinking often left people speechless. His work didn't just break technical barriers, it fundamentally challenged the way we understood the world. Picture this: with just a simple metal wire, a small oscillator, and a receiver, Hertz shattered the boundary between electricity and light. It wasn't just about demonstrating electromagnetic waves, it was about showing the world that science could truly unlock the unknown. Hertz's experiments didn't just revolutionize the field of physics, they sparked a massive shift in how science itself was approached. Before Hertz, scientists were more focused on pure theory, but Hertz bridged the gap between theory and practice. He believed that scientific discoveries should be tested in real life, not just on paper. This theory and practice go hand-in-hand mindset was revolutionary for its time. He didn't just make the abstract concrete, he showed the world how to make theoretical physics relevant to the real world. When Hertz proved the existence of electromagnetic waves, he didn't just stop at the success of the experiment. He recognized that this wasn't just an academic exercise, it was the key to future technology. His experiments didn't just demonstrate the theoretical possibilities, they laid the foundation for what would become wireless communication, broadcasting, and beyond. Hertz's experiments weren't just about validating Maxwell's theory, they were about pushing the limits of what was possible. He proved that electromagnetic waves weren't just a nice-to-have theory, they could be used to change the world. And his work would go on to influence future inventors like Marconi and Tesla. You probably know Marconi as the man who helped pioneer wireless communication. But did you know he got much of his inspiration from Hertz's experiments? By proving that electromagnetic waves could travel long distances, Hertz gave Marconi the theoretical framework he needed to transmit signals wirelessly, breaking the chains of space and distance. Marconi used Hertz's findings to bring radio communication to life, forever changing the world. And Tesla? He took it a step further, pushing the development of both radio and alternating current, ushering in a new age of technology. Hertz's influence wasn't just limited to the realm of physics. His theory and practice approach also impacted the fields of engineering, computer science, and more. Future pioneers, including Einstein, drew inspiration from Hertz's work, which helped push physics into the modern era. His interdisciplinary approach, combining math, physics, and engineering, was a blueprint for the future of science. In fact, Hertz's methods didn't just change physics, they laid the foundation for the entire information age. His focus on experimentation, combined with theory, helped create the technologies that power the digital world today. When we look back at Hertz's work, it's not just about the physics of electromagnetic waves. It's about how he showed us that real-world experimentation and theory go hand in hand. His legacy is a reminder that scientific exploration isn't just about theoretical knowledge, it's about using that knowledge to build the future. Just as Hertz transformed our understanding of the physical world, we can use science to transform our future. You might be wondering, what makes Hertz so important beyond just his work with radio? Well, his electromagnetic wave experiments laid the foundation for television and broadcast technologies too. Think about it, without Hertz's experiments, how would broadcast and TV even exist? Before him, scientists had started to grasp the connection between light and electromagnetic waves, but without Hertz's proof, we might still be stuck in the electromagnetic waves or just a theory phase. TV sets and radios might still be nothing more than fantasies. But thanks to his research, the door was opened to technologies that let us see and hear across vast distances, changing the world forever. Hertz's discoveries didn't just revolutionize radio communication, they unlocked countless doors for modern tech. From early 20th century radio and television to today's smartphones, satellite communications, and radar technology, Hertz's electromagnetic waves are quietly powering everything we rely on. Think about it: Wi-Fi, Bluetooth, and even the GSM and 5G networks we use today all have their roots in Hertz's research. So, next time you're in a coffee shop browsing on your phone, give a quiet thanks to Hertz and his groundbreaking experiments. Radar and satellite communications, some of today's most advanced technologies, owe a huge debt to Hertz. Early radar systems, for example, relied on the reflection properties of electromagnetic waves, and his experiments provided the foundation for that knowledge. When it comes to satellite communications, Hertz's theories about how electromagnetic waves propagate through space are still crucial for transmitting signals to far-off satellites. Whether it's distant satellites or those invisible Wi-Fi signals floating through the air, Hertz's influence hasn't faded, it's still with us today. Hertz didn't just bring wireless communication to life through sound waves, he made it possible to send information over long distances with no obstacles. Today, when we pick up our smartphones, surf the web, or play video games online, we're benefiting from his work, and we don't even realize it. Whether it's the phone in your pocket or the Wi-Fi in your home, it's all thanks to Hertz's pioneering experiments with electromagnetic waves. From radio to TV, and now the internet and smartphones, Hertz's electromagnetic wave experiments weren't just scientific breakthroughs, they were the key that unlocked the rapid growth of modern communication technology. He didn't just change the face of physics, he laid the foundation for the transformation of our society. Think about it: today, you can receive TV broadcasts, listen to the radio, or watch videos on your phone anytime, anywhere, all thanks to Hertz's work. Ever wondered how this all became possible? Well, that bridge of communication was built by Hertz long ago. Hertz wasn't just a trailblazer in the lab, he was one of the founding fathers of modern communication technology. His work has had a profound impact on the world we live in today, from the invention of radio to the widespread use of television and the development of satellite communications, Wi-Fi, and 5G. Hertz's electromagnetic wave experiments laid the irreplaceable scientific foundation for all of these technologies, opening up a bright future that we're still living in. Now, you might ask, how did Hertz's electromagnetic wave experiments affect radio broadcasting? Well, let's talk about his experiment setup for a second. Picture a young physicist standing in his lab, adjusting his oscillator, carefully watching his receiver, and then bam, he discovers the secret of electromagnetic waves. You might think, oh, just another experiment. But no. This was the foundation for radio technology. Hertz's work was the catalyst for the commercialization of radio technology. While he didn't personally invent radio, his experiments established the solid scientific foundation for its application. His work directly validated Maxwell's electromagnetic wave theory, confirmed the existence of electromagnetic waves, and showed that they could propagate like light waves. Can you imagine, without Hertz's experiments, we might still be in the dark about radio technology, and the entire wireless communication field could be non-existent. Hertz's electromagnetic wave experiments paved the way for the invention of radio, fundamentally changing how we transmit information. Every time you use your phone, listen to the radio, or watch TV, remember it's all tied back to Hertz's contributions. His experiments provided the scientific support for radio technology, and radio's application has deeply affected our daily lives. The advent of radio wasn't just a huge scientific milestone, it was the start of a new era, one where we could communicate across space and time. Hertz's experiments were the beginning of it all. Think about it: from the earliest days of radio broadcasting to today's global satellite communication, Hertz's work gave us the theoretical basis for these technologies, which in turn changed how we share information. News can spread across the globe in seconds, entertainment can cross continents via wireless signals, and remote communication became a reality. Hertz didn't just push forward radio, He laid the groundwork for broadcasting, television, and the modern communication networks we take for granted today. Without him, we might still be relying on postal workers, and smartphones would be a distant dream. Hertz was a genius in the academic world, and his experiments changed everything. But here's the thing you might not know: Hertz was also quite the humorous guy, and he was just as popular outside the academic world as he was in it. You might think someone as deeply immersed in physics as Hertz would be all about formulas and experiments, right? But surprisingly, his humor was legendary in the scientific community. He wasn't just about serious research, he was also the kind of guy who could make people laugh in the midst of intense academic discussions. His humor made him incredibly well liked, and it wasn't just his colleagues who enjoyed his wit. Prominent figures like Helmholtz and Planck admired Hertz's sharp mind and sense of humor. Physics, math, and chemistry can be pretty cold subjects, but Hertz had a way of making them fun. Even at the most serious academic meetings, he could lighten the mood with a joke, which helped make his research more accessible to everyone and earned him a lot of friends along the way. And when it came to family, Hertz was no different. Despite his busy career, he cherished his time with his family. His relationship with his wife and children was warm and supportive, providing him with the strength to balance work and life. Scientists need a foundation of love and support, and Hertz had that in spades. His wife wasn't just a supporting character, she was one of his strongest allies in both life and work. So, while Hertz's name is often associated with rigorous experiments and complex theories, his personal life was warm, humorous, and full of love. He was a star in the academic world but also a ray of sunshine in everyday life. Hertz's contributions weren't just to physics. He changed the face of modern technology, even shaping today's communications and broadcasting world. You might not realize it, but every time you use your phone, watch TV, or connect to Wi-Fi, Hertz's influence is quietly at work. The physicist you might not have heard of is, in fact, one of the founding fathers of wireless communication technology. Hertz is often called the father of modern electromagnetic waves and wireless communication. And that's not an exaggeration. His electromagnetic wave experiments didn't just solve a bunch of scientific problems, they laid the groundwork for radio technology's birth. Imagine a time before Wi-Fi, and Hertz could already foresee the potential of electromagnetic waves to transmit information. He used precise experiments to prove Maxwell's electromagnetic wave theory, successfully creating electromagnetic waves in the lab, and paved the way for radio, TV, and even today's internet. Hertz's academic legacy is immense, especially in the field of electromagnetic wave propagation. Today's wireless communication technologies, including radio, TV, radar, and even satellite communication, all trace back to Hertz's research. He wasn't just an experimenter, he was a trailblazer. Hertz's experiments shattered our understanding of electromagnetic waves, freeing us from the constraints of wired communication and ushering in a new era of wireless technology. When you snap a photo on your phone, send a text, or watch TV wirelessly, Hertz's contributions are like invisible waves shaping our daily lives. But Hertz didn't just win accolades for himself. His scientific ideas provided a foundation for future physicists, engineers, and tech developers. Can you imagine today's tech, fiber optics, 3G, 4G, or even 5G without Hertz's theoretical groundwork? His work didn't just shape modern communication, it influenced the pace of technological progress itself. From radio to satellite communication, Hertz played a vital role at every step. So, today, whether you're using your smartphone, watching TV, or enjoying Wi-Fi, Hertz's research is likely supporting you. Doesn't it make you realize just how crucial Hertz was? He wasn't just a physicist, he was the invisible giant behind communication tech. Hertz's electromagnetic wave experiments laid the foundation for the core of modern technology. The wireless communication and broadcast technologies we use every day are all thanks to that pivotal moment in his lab. Hertz didn't just provide the theoretical foundation for wireless communication technology, he also pushed the application of many modern technologies forward. His experiments became the cornerstone of modern communication and broadcasting. Today, global information transmission, satellite communication, and remote connections all depend on the inspiration of Hertz's research. His discovery was like planting a seed in the fertile soil of technology, growing into all the tech we depend on today. Hertz's work changed the world, driving the progress of modern society. No matter where you are, Hertz's contributions have left their mark on your life. So, next time you enjoy the convenience of wireless networks or tune into a broadcast, take a moment to think about the world-changing story behind Hertz's experiments. The people who change the world. Usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.